Multi-tenant architecture has emerged as a cornerstone of modern cloud computing, fundamentally transforming how organizations design and deploy software solutions. This presentation examines the principles, implementation strategies, and best practices for building robust multi-tenant system in today's rapidly evolving technological landscape. Multi-tenancy is a powerful architecture approach where a single software application simultaneously serves multiple independent organizations called tenants. Each tenant experienced the application as if they were on their own dedicated instances, while behind the scene, they share the infrastructure resources efficiently. This model ensures complete data isolation and customization capabilities while maximizing resource utilization and reducing operational costs. Imagine an apartment building where different people rent different apartments. Each person lives independently, but they all share the same building. In the world of software, a multi-tenant system works the same way. Instead of apartment, different companies or customers share the same software but have their own separate spaces, like their own data and settings. This allows businesses to save on cost as they don't need to build new systems for each tenant. The multi-tenant model revolutionized software delivery in early 2000s, coinciding with the emergence of cloud computing and SaaS platforms. Before this innovation, organizations had to deploy and maintain separate application instances for each customer, leading to significant overhead and complexity. Today's sophisticated multi-tenant architecture have evolved to support advanced features like tenant-specific customization, dynamic resource allocation, and seamless scalability across all application tiers. Importance in modern software architecture. Resource optimization. Multi-tenancy maximizes return on investment by intelligently sharing computing resources across customers while ensuring complete data isolation. This approach dramatically reduces infrastructure costs while maintaining enterprise-grade security standards. Operational efficiency. By centralizing maintenance and update across all tenants, multi-tenant architecture reduces development cost and deployment times. Teams can focus on innovation rather than managing separate instances. Strategic necessity. In today's competitive landscape, multi-tenancy is key for business growth. It helps companies to scale fast, keep performance high, and lower the cost, giving them a strong competitive edge. Difference between multi-tenant architecture and single-tenant architecture. Resource isolation. Dedicated infrastructure with complete isolation for single-tenant applications. Multi-tenant application has virtual isolation through data partitioning. Cost efficiency. Higher cost due to dedicated resources for single-tenant architecture applications. In multi-tenant applications, lower cost due to shared infrastructure. Unlimited customization potential. Each tenant can have custom features, configuration, and settings for single-tenant applications. In multi-tenant application, configurable is limited due to platform constraints. Since all tenants share the same software, it's harder to provide specific customization for each tenant without affecting others. Maintenance. Quick updates and maintenance cycle needed for single-tenant application. Each instance needs to be maintained individually, increasing overhead for updates and bug fixes. Since multi-tenant applications are single code base, the simultaneous update can be performed. Update and bug fixes can be applied to the entire system at once and deployed at the same time. Core components of multi-tenant system are tenant identification and authentication, data isolation strategies, resource management. Tenant identification and authentication provides a secure access management at both tenant and user level, ensuring each organization maintains complete control over their users and permission while protecting sensitive data. One of the most important goals in multi-tenancy is to make sure that tenants are isolated from each other. Data isolation strategies ensure complete separation of tenant data through multiple security layers, guaranteeing that each organization's information remain private and secure while sharing the same infrastructure. Resource management intelligently allocates and monitors system resources to deliver optimal performance for each tenant, automatically scaling resources up or down based on individual needs. With the multiple tenants using same system, ensuring the system performs well for all users is critical. If one tenant experiences slow performance or downtime, it could affect all the tenants. Data architecture and storage pattern. First option is shared database and shared tables. All tenants use the same database and the tables, but each row is marked by tenant ID to ensure separation. This is the most cost-effective approach. Second option is shared database and separate tables. In this case, database is same, but for each tenant, separate tables and schemas will be created. Third option is separate database, complete tenant isolation with the dedicated databases, offering maximum security and customization but higher infrastructure maintenance costs. Security implementation, authentication mechanisms. Ensure top security with zero trust model that verifies every request in each layer of the application. Use JSON Web Token for stateless authentication. Authorization framework. Control access with role-based access control and attribute-based rules. Dynamically grants permission based on user context and security policies for strong protection. Data privacy controls. Protect sensitive data with the built-in privacy measures. Use smart data classification and geographic controls to ensure compliance across regions. Cross-tenant security measures. Ensure strong isolation between tenant with advanced network segmentation and monitoring. Uses real-time threat detection and resource limits to prevent security risks. Performance and scalability. Resource allocation. Automatically scales computing resources up and down based on real-time demand, ensuring cost-efficient operation while maintaining performance. Caching mechanism. Speeds up data access by storing frequently used information across strategic network location with separate cache for each tenant. Load balancing distributes workload intelligently across servers based on the capacity and response time and tenant priorities to prevent bottleneck. Monitoring and optimization continuously track system health and performance using AI to detect issues before they impact users and automatically optimize the operations. Peak load handling. Anticipate and manage high traffic periods through automated scaling and smart request prioritization, ensuring consistent performance. All architecture choices has trade-off. Multi-tenancy also have challenges. Data isolation. Maintaining strict tenant data segregation while optimizing shared resources requires sophisticated database partitioning strategies. Critical challenges include preventing data leaks across tenant boundaries, implementing row-level security, and ensuring compliance with the data residency requirements. Performance variability, preventing noisy neighbor effects where a high usage tenant impacts others. Performance requires intelligent resource governance. Key challenges include implementing fair scheduling algorithms, managing tenant-specific SLAs, and maintaining responsiveness during the peak loads. Customization limit. Supporting tenant-specific configuration while maintaining a unified code base demands careful architecture decisions. This includes managing schema variations, handling custom workflows, and implementing feature toggles without compromising system maintainability or scalability. Future trends in multi-tenant architecture. AI-driven optimization. Machine learning algorithms are revolutionizing multi-tenant environment by dynamically predicting resource needs hours in advance. This system automatically optimizes database queries, fine-tune cache strategies, and proactively scale infrastructure based on sophisticated usage pattern and tenant behavior analytics. Serverless multi-tenancy. Next generation serverless platforms are transforming tenant isolation through advanced container organization and microsecond level billing. Organizations are achieving up to 40% cost savings while gaining instant scalability and zero maintenance operation through services like AWS Lambda and Azure Functions. Edge computing integration. Distributed edge architecture are dramatically reducing latency from 100 millisecond under 10 millisecond for multi-tenant application. By deploying containerized microservices across global edge location, businesses are delivering near real-time experience for IoT devices, augmented reality or virtual reality applications, and mobile users. Advanced security paradigm. Revolutionary security frameworks are emerging that combine zero trust architecture with AI-powered threat detection, achieving 99.9 and breach prevention rates. Implementation of quantum-resistant encryption and decentralized identity management is preparing multi-tenant system for post-quantum era. The architecture has changed cloud computing by optimizing resources and cutting costs. It makes enterprise-level solution affordable for all business while reducing environmental impact. Success in multi-tenancy requires strong security, strict data isolation, and optimized performance. It also needs continuous monitoring and proactive maintenance to keep things running and smoothly. With AI and cloud and advancement, multi-tenancy is becoming smarter and more autonomous. It enables systems to self-optimize, adapt to business needs, and stay secure and reliable. Thank you.